Hi there, and welcome back to my Precalculus video series, where my goal is simple: to make Precalculus make sense. Whether you're here to get ahead, catch up, or just finally understand what your textbook is trying to say, you are in the right place. In our previous lesson, we explored the real number system, the incredible universe of numbers that we're going to be working with throughout our study of Precalculus. Today's focus is on the properties of real numbers, and by the end of this video, you will be able to 1. Identify and define the commutative, associative, and distributive properties of real numbers. 2. Apply these properties to simplify expressions involving addition and multiplication. 3. Recognize when each property is being used in algebraic manipulations. And 4. Understand the fundamental role these properties play in all of algebra and precalculus. I want you to follow along with a set of guided notes I've created for this lesson, which can be found in the description of this video. Thank you for being here. Now let's get started. Have you ever noticed that 2 plus 3 gives you the same result as 3 plus 2? Because this is 5 and this is also 5. Have you also noticed that if I do 2 times 3 and I multiply that by 4, it's the same thing as 2 multiplied by 3 times 4 separately? Because 2 times 3 is 6, times 4 is 24. And that is equal to 2 times, well, what's 3 times 4? 12. 12 times 2 is also 24. It almost seems obvious, right? But why do these simple operations always work that way? And does this so-called flexibility apply to all operations, like subtraction or division? What happens when we introduce variables? Today, we're zooming in on the fundamental rules that underpin all of arithmetic and algebra. You've been using these properties your entire life without even realizing it. Now you're finally going to learn their official names and understand them. The 3 properties we're focusing on today are the building blocks for simplifying expressions and solving equations. Let's start with a very intuitive one. First is the commutative property. Think of commuting or commuting to work. It's about changing position or order. This property simply states that you can change the order of numbers in addition or multiplication without changing the final result. Let's first begin with addition. If I have a plus b, that is going to be equal to b plus a. I can reverse the order, but I'm not going to change the result. So if I have 7 apples, and then I add 3 more, that's the same thing as if I start off with 3 apples and then I add 7. 7 plus 3 is 10, and 3 plus 7 is also 10. Both give you 10. So we can say 7 plus 3 is equal to 3 plus 7. For multiplication, we can say something similar. If I have a multiplied with b, that's the same thing as b multiplied with a. So if I have 5 times 4, that's 20. That's the same thing as if I have 4 times 5. That is also 20. So I can say 5 times 4 is the same thing as 4 times 5. Here's an important note. This property does not apply to subtraction or division. Let's take an example. If I have 5 minus 3, is that the same as 3 minus 5? Well, 5 minus 3 is positive 2, but does that equal to 3 minus 5, which is negative 2? The answer is no. 2 does not equal to negative 2. So that is why subtraction does not work with a commutative property. Let's try one for division. Is 10 divided by 2 equal to 2 divided by 10? Well, 10 divided by 2 is 5. And I know 5 is not equal to 0.2. Next up is the associative property. Think of associating or forming a group. This property deals with how you group numbers when performing addition or multiplication with 3 or more terms. It states that the way you group the numbers with parentheses does not affect the final result. Let's see how this works with addition. The general rule is that if I have a plus b in parentheses being added and I add c to that, that is the same thing as if I have a and then I add b plus c in parentheses together. So let's imagine that we're adding 2 plus 4 plus 7. But I'm going to change the order in which I add. On the left-hand side, I'm going to add 2 plus 4 first. And on the right-hand side, I'm going to add 4 plus 7 first. Well, 2 plus 4 is 6, and then plus 7. On the right-hand side, I have 2 plus 4 plus 7 is 11. I know on my right-hand side, 11 and 2 is 13, and 6 plus 7 is also 13. So because 13 is equal to 13, I get this statement to be true. For multiplication, it does not matter the order in which I multiply numbers. If I have A multiplied by B and then I multiply C on the outside, that is the same thing as if I have A and then I multiply B and C together at the same time. Now let's consider 3 times 7 times 5. On the left-hand side, I'm going to multiply 3 and 7 first. And on the right-hand side, I'm going to multiply 7 and 5 first. So on the left-hand side, 3 times 7 is 21. And I'm multiplying that by 5. Over here, I have 3, and 7 times 5 gives me 35. So 21 times 5, that is 105. And if I multiply 3 times 35, I also get 105. So I know this statement is true. The parentheses typically tell us what operation to perform first. The associative property tells us that for only addition and multiplication, those grouping choices are flexible without changing the final sum or product. Lastly, let's talk about the distributive property. The distributive property is really important because it connects multiplication with addition, also subtraction, in a very powerful way. This property allows you to multiply a single term by 2 or more terms inside a set of parentheses. Let's see the rule for the distributive property. If I have A being multiplied by a sum B plus C, the distributive property says I can multiply A by each of the terms inside the parentheses. So I would get AB plus AC. Now let's do a quick example to visualize this. If I have 2 multiplied by 3 plus 5, according to the order of operations, I have to do what's inside the parentheses first, which is 3 plus 5, which would be 8. So I would simplify this to be 2 times 8, and my answer would be 16. The distributive property says we can distribute the 2 like so. So I can distribute 2 and multiply by the 3. So this would be 2 times 3, and then I'm also going to distribute it to the 5. Plus 2 times 5. Well, 2 times 3 is 6, and 2 times 5 is 10, and that also gives me the result of 16. So both methods yield the same result. This is precisely what you're doing when you distribute a number or a variable into a binomial, or simplify expressions like 2 times x plus 3 to be 2x plus 6. Because you take the 2 and you multiply it by x. What's x multiplied by 2? Just 2x. And what's 2 multiplied by 3? Just a 6. And we keep the plus sign in the same position in which it was. This is a fundamental step in algebra. And yes, this property works even when the single term is after the parentheses. And so I write it like this. B plus C be multiplied by A, but A is not on the left-hand side anymore. Now it's on the right. It doesn't matter at all. I can still distribute the A into each term. I can get BA plus CA. But as we know, because of the commutative property, like so over here, it does not matter the order in which I multiply my terms or my numbers. So these two are equivalent to one another. I've just shown you how to simplify an expression like 2 times x plus 3 using the distributive property. Let's try something a little bit more interesting. In this example, we're going to expand and simplify a plus b multiplied by x plus y. Here's one way you can think about this. Just like the way we took the 2 and we multiplied it by each of the terms inside, you can do the same thing with the entire a plus b. It may not look the same, but you're using the same rules. So you can do this whether there's a plus b or a plus b plus c plus d plus e. So a plus b, I'm going to take the whole thing and I'm going to multiply it by x. And that's going to look like this. A plus b all be multiplied by x. And then I'm going to take a plus b and multiply it by y. And because I have a plus sign between these, I'm going to be adding them together. So I'm going to get a plus b multiplied by y. Now, this looks like this form of the distributive property. So just because the x is on the right-hand side, it's still the same thing as this original first one. So what I can do is that I can distribute the x into a and b and the y into a and b. So let's start with x times a, that is ax. X times b is bx. And here I have a plus sign. Y times a is ay. And then plus y times b, which I can write as by. I could also write it like this, xa plus xb plus ya plus yb as well. It is all the same thing. Those two are equivalent. Now, when you're doing problems like this, you need to pay careful attention to the signs of these terms. or the signs of the numbers that you're dealing with. Because A is positive, B is positive, and X is positive, I don't need to pay attention to the signs. A positive times a positive is going to result in a positive. Since everything is positive, I just need to multiply the terms. But if you had minus signs in here, like A minus B, you need to pay careful attention to that and follow those rules of multiplication. So this is one way that you can think about it. But another way that you could simplify this is to use the FOIL method if you're familiar with it. The FOIL method stands for first, outer, inner, and last. If you're not familiar, let me show you how you could achieve the same result right here using the FOIL method. So starting with the original problem, A plus B times X plus Y. So the first step is to take the first term, and then you're going to multiply it by the first term of the second set of parentheses, A times X. So that's going to give me AX. Then the outer, I'm going to take A and multiply it by the outer one, A times Y, so plus AY. Then I'm going to do the inner ones together, B times X, so plus B times X. And then finally the last pair, B times Y plus BY. And so you get the exact same answer as what we achieved up here. So they're two separate methods, but they achieve the same result. Time for a quick check of your understanding. Which property, the commutative, associative, or distributive property, justifies the steps shown here? 6x plus 4 multiplied by 2 equals to 12x plus 8. Is it the commutative, the associative, or the distributive? The answer for this is the distributive property. We multiplied the 2 by the 4 and the 2 by the 6x to give us our final result. Let's quickly recap the three essential properties of real numbers. First is the commutative property, which says that the order of addition or multiplication does not matter. And so we saw both A plus B is equal to B plus A, and that A times B is the same as B times A. Secondly is the associative property, which says that the grouping of addition or multiplication doesn't matter. And we saw this property here. A plus B grouped together added with C is equal to A plus the grouping addition of B plus C. Same thing for multiplication. A and B grouped together, being multiplied, times C on the outside is the same thing as A on the outside with the multiplication of B times C grouped together. Third is the distributive property, which just says that multiplication distributes over addition. And we saw this property. These two, you can pick whichever version that you like, but you just need to be familiar with both, so that way you can recognize it when it comes up. These three properties are not just abstract rules. They are the fundamental operations that underpin almost everything we do in algebra, from simplifying complex expressions to solving equations themselves. Getting comfortable with them now will set you up for success throughout precalculus and beyond. In our next video, we'll build directly on this foundation as we explore addition and subtraction of real numbers, including the special role of zero, and dive into the properties of negatives. You'll see how understanding these properties is key to working seamlessly with positive and negative numbers. If this video helped you, please hit that like button and subscribe so that you don't miss the next lesson. Thank you for spending some time with me, and I'll see you in the next lesson.